Here's a picture of a classical atom, or a model, I should say, of a classical atom. In the classical models, there are no defined energy levels. So you can see as we're adding heat, the electron's orbit is expanding with each revolution. The electron's energy is gradually increasing. This atom is not bound by any quantum considerations. Any energy is possible. So there's a continuum of energies. As you can see, the electron is getting farther and farther from the nucleus. That increases its potential energy. You can also imagine that the electron will reach a time when its energy reaches zero. That will free the electron from the nucleus. If it reaches zero, it is no longer bound. It will escape. That's the classical atom. Every energy is possible. Here we're now contrasting the classical atom with a quantum atom. Heat is applied to the atom, but the electron is staying in its same energy level. So you can see a flat line here on the energy graph. This is a quantum state. This happens to be quantum state number 1 for this particular atom. Energy level 1, quantum state 1. I will change to energy level 2, quantum state 2. This would be a sudden transition, not a gradual electron getting farther and farther away, but a sudden, all at once, the electron is in a different energy state. Bohr used orbits to describe these quantum states and was very successful with his model. You can see this is a different energy here on the graph. It's a constant energy, but it's a very large difference from the original energy. This is quantum state number 2. No energy between these two is allowed. This electron can either be at this negative 11 point something energy level or at the negative 22 point something energy level. Nothing in between exists. My model here on the screen also has a third energy level. So in the Bohr model, these are orbits. In the more modern model, these would be considered shells. But every modern atomic model incorporates the idea of quantum energy states, quantized energy states, where only specific energies are allowed. This is what makes it so that only specific energies of photons can be produced. There will be a photon if the electron were to go from level 3 to level 2. A specific energy photon would be produced. It would be equal to the difference in energy between these states in the energy graph. The electron could drop from 3 to 1, all the way from 3 out here to 1, and that would be a different kind of photon. So the quantum nature of the atom is intricately related to the quantum nature of photons.